Hello friends, welcome back to my channel again in Mind and Maths. In last day, we have solved some numerical problems in number systems, and today also we will be solving some more problems. In the last lecture, we have solved up to question number 13, and today we will be solving from question number 14. So let us start. So what is there in question number 14? Please read it. Express the following in the form P by Q, where P and Q are integers and Q is not equal to 0. The first one is 5.2 bar. So let us solve it. Let us take x is equal to 5.2 bar. Now what we are going to do is we are going to separate the repeating or the recurring portions of this number. How? We can write it as 5 plus 0.2 bar. Then say y is equal to 0.2 bar, or we can write it as y is equal to 0.222 dot dot dot, or we'll multiply it with 10 on both sides. So 10y is equal to 2.222 dot dot dot, or 10y is equal to 2 plus 0.222, or 10y is equal to 2 plus, we have taken this 0.222 dot 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 is equal to y, so we can write it as y, or 9y is equal to 2, or y is equal to 2 by 9. Let us take this is equal to equation 1. So putting the value of y is equal to 2 by 9 in equation 1, we get what we get. X is equal to 5 plus 2 by 9, that is equal to 5 nines are 45 plus 2 47 by 9. So this is the answer, 47 by 9. Okay, so now the next one is 0.323232 dot dot dot. So let us take x is equal to 0.00323232 and so on. So here the same method we will apply. This 0.00323232 dot 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 means 0.0032 bar. So what we are going to do is we are going to separate this 32 bar from the other portion of the number. So how we are going to do it? We are going to multiply 100 on both sides, and let us see what happens. This is 100x is equal to 0.323232 dot 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 bar. So now again we can say y is equal to 0.3232 dot dot dot, or we will multiply it with 100 again, 100 on both sides, 32.3232 dot dot dot. So it is 100y is equal to 32 plus 0.323232 dot dot dot, or 100y is equal to 32 plus, what is this? This is equal to y, or we are taking this y on left side, it will become 99y is equal to 32, or y is equal to 32 by 99. So we are going to put this value in this equation and we'll see what it shows. 100x is equal to 32 by 99, or x is equal to 32 by 9900. Okay, and this will come out to be 8 by 2475. And in short method, we can do what we can do is, we are taking x is equal to 0.003232 dot dot dot, or x 100x is equal to 0.3232 dot dot dot, and this is equal to 0.32 bar, and we can directly write it as 0.32 bar means 32 by 99. So x will become 32 by 9900, that is equal to 8 by 2475. For any number we can do it like that. Suppose it is 0.12345 bar, then this is equal to 12345 bar by how many digits are there? 1 2 3 4 5. 5 digits means 5 numbers of 9. 1 2 3 4 5. Okay. Similarly, if it is a b c d e dot 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 n times are there, bar 0 point, it will be like a b c d e dot 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 n times by 9999 dot 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 n times. We have discussed it in earlier classes also. Okay, so we have completed the second problem. Similarly, we will be solving the third one also. Say x is equal to 0.2555 dot dot dot. Which one is the repeating one? This 5555. So we have to separate this 555 dot 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 from this point 2. Okay, how? We will multiply it with 10 on both sides. So it will become 2.555 and so on. So 10x is equal to 2 plus 0.555 dot dot dot, or 10x is equal to 2 plus 0.5 bar. Okay, so how we can write it? 10x is equal to 2 plus 5 by 9, right? Or 10x is equal to 23 by 9, or x is equal to 23 by 90, right? Now the question number 15. Simplify the following. Fourth root of 81 minus 8 into third root of 216 plus 15 into fifth root of 32 plus square root of 225. It looks bigger but not that difficult problem. This is equal to 81 to the power 1 by 4 minus 8 into 216 whole to the power 1 by 3 plus 15 into 32 to the power 1 by 5 plus 225 to the power 1 by 2. So this 81, can we write it as 3 to the power 4 whole to the power 1 by 4? 3 3 is a 9, 3 is a 27, 3 is a 81. 3 3 is a 9, 3 is a 27, 3 is a 81. So we can write it as 3 to the power 1 by 4 minus 8 into, what is this 216? Cube root of 216? 6 6 36 into 6. If we do 6 6 36, 6 3 in hand, 3 6 3 is 18 plus 3 21. That means 6 into 6 into 6 is 216. That means 6 cube is equal to 216 whole to the power 1 by 3 plus 15 into 32 is 2 to the power 5 2 to the power 5 is equal to 32 whole to the power 1 by 5 plus this 15 into 15. If you do 15 into 15, that is equal to 225. So square root of 15 into 15, so square root of 225 is equal to 15. We are directly writing it. So what is this? 3 to the power 4 into whole to the power 1 by 4. This is equal to 3 to the power 4 into 1 by 4 minus this 8 into 6 cube into 1 by 3 plus 15 into 2 to the power 5 into 1 by 5 plus 15. So this is equal to 3 minus 8 into 6 plus 15 into 2 plus 15. This is 3 minus 8 6 are 48 plus 15 2s are 30 plus 15. So what will be the answer? Calculate it. It will be 0. Right? Easy? Okay. Question number 16. Find the values of A and B for this expression, this equation. Okay. So let us try to solve. We will try to solve from left hand side, LHS. 7 plus root 5 by 7 minus root 5 minus 7 minus root 5 by 7 plus root 5. Can we write it as 7 minus root 5 into 7 plus root 5? So in the numerator what we will do? This into this 7 plus root 5 whole square minus this into this 7 minus root 5 whole square. Okay. This is a plus b whole square. A square plus 2ab plus b square minus, let us write it within bracket, a square minus 2 into a into b plus b square. And this is a minus b into a plus b, that is equal to a square minus b square. So this is 7 square means 49 plus 14 root 5 plus 5 minus 7 square means 49. This minus and minus becomes plus. This 14 root 5 plus, no sorry, this plus and minus becomes minus 5. This 7 sevens are 49 minus 5. So this is 28, 14, 14, 28 root 5 by 44. This is 7 root 5 by 11. So what we can write? This 7 plus root 5 by 7 minus root 5 minus 7 minus root 5 by 7 plus root 5 is equal to a plus 7 by 11 root 5 into b, or this value what we are getting, this is equal to 7 root 5 by 11. So 7 root 5 by 11 is equal to a plus 7 by 11 root 5 into b, or to match it, what we are doing, we are writing 0 plus 7 by 11 root 5 into 1 is equal to a plus 7 by 11 root 5 into b. Now if we match from LHS to RHS, what we will get? 0 is equal to a, so that is a is equal to 0, and this 1 is equal to b, this b is equal to 1. So we have got the values of a and b, right? Now question number 17. If a is equal to 2 plus root 3, then find the values of a minus 1 by a. So how we will solve this question? A minus 1 by a. So we know this is a, and let us find out what is 1 by a. Then maybe we will be able to find, we'll be able to solve it. Okay. What is 1 by a? 1 by a is equal to 1 by 2 plus root 3. In the denominator side, it is not rational. Let us rationalize it. How? We'll multiply with 2 minus root 3 on both numerator and denominator and see what we get. A plus b into a minus b. So we have got 1 by a is equal to 2 minus root 3 and a is equal to 2 plus root 3. So very easy. So hence a minus 1 by a is equal to a plus root 3 minus 2 minus root 3. Sorry, this is not a, this is 2. So 2 plus root 3 minus 2 plus root 3, that is equal to 2 root 3, right? Now let's solve this one. Express 0.6 plus 0.7 bar plus 0.47 bar. The bar is on 7 only, in the form p by q, where p and q are integers and q is not equal to 0. चलो देखते हैं. Can we solve it directly without considering, say, let's this is x, this is y. Can we solve it? See if we can solve it or not. This is 0.6. We are writing as it is, and you know what is 0.7 bar is equal to. If we directly write it, this is equal to 7 by 9. So for solving quickly, we can do it. If it is a multiple type question, then we can solve it like this way. Or you have to do separately. Suppose this is equal to x or this is equal to y, like that you have to solve how we have solved in earlier questions. Okay, and see how we are writing this. Can we write it as 0.4 plus 0.07 bar? Can we write? Think. If we multiply if we add 0.07 bar with 0.4, we are adding here 0. After decimal, we can add this 0. It will show nothing. So this will become the 0 and 7 bar is also 7 bar, and this is 4 and 0 becomes 4. So point and 0. So this 0.4 and 0.07 bar is equal to 0.47 bar. We can write it like this. Okay. So now we can write 0.6 as 6 by 10, 7, then 7 by 9 plus we can write 0.4 is equal to 4 by 10, or this 0.07 bar we can write as 0.7 bar by 10. If we multiply both sides with 10, we can write it like that. This 0.07 bar is equal to 0.07 bar into 10 by 10. So this will become 0.7 bar by 10. That is what I have written here. We can write. Okay. So 6 by 10 plus 7 by 9 plus 4 by 10 plus. So this is what I am writing. 1 by 10 into 0.7 bar. And now what is 0.7 bar? 0.7 bar is equal to 7 by 9. 0.7 bar by 10 is equal to 1 by 10 into 0.7 bar. So 1 by 10 into 7 by 9. That is what I have written here. Okay. So now it has become easy. So what will this become? 6 into 9 plus 7 into 10 plus 4 into 9 plus 7. So 6 nines are 54 plus 7 tens are 70 plus 4 nines are 36 plus 7 by 90. So how much this will become? This will become 167 by 90. This looks difficult, but this is not very difficult problem. If it is a long answer type question, then you have to separate these three parts. You have to say that suppose x is equal to 0.7 bar, and then you have to solve this part, and then y is equal to 0.47 bar, then again you have to do 10y is equal to 4.7 bar, or 10y is equal to 4 plus 0.7 bar, then again you have to solve it and write like that you have to do, and for to get the quick answer you can solve it like this way. Okay, if you practice more, you will get confidence to solve this kind of questions. Now there is an important note, please listen carefully. There are three conditions given. What are the three conditions? First one is if a is a positive rational number. A is a positive rational number. Second condition is if n is a natural number. N is a natural number. And the third condition is nth root of a is an irrational number. Nth root of a is an irrational number. Then n root a is called a simple surd or monomial surd. Okay. If the three conditions are satisfied, then this is called a monomial surd. Let us take with examples. Suppose root 3. Root 3 means square root of 3 or second root of 3. Here we can consider this is 2. 2 root of 3 or square root of 3, whatever you call this. This, can you say that this is a surd or not? Yes, this is a surd. Why? Let us see whether this satisfies all these three conditions. Well, here, what is A? If we compare it with this one with n root of A, then here n is equal to 2 and A is equal to 3. So the first condition is A has to be a positive rational number. Positive rational number. So the number one condition satisfies. Now n has to be a natural number. N is equal to 2. This is a natural number. So this satisfies the condition number 2 also. Okay, let us see whether it satisfies the condition number 3. This nth root of a has to be an irrational number. Nth root of a means 2 root of 3. Is this an irrational number? Yes, this is obviously an irrational number. So this satisfies the condition 3 also. So this 2 root 3 is a surd. Okay. Now let us take another example. Whether this 2 root of 9 is a surd or not. Let us see the first one whether it satisfies or not. First one here, this, if you compare it with n root of a, then first one is a that is equal to 9 has to be a positive rational number. So the first one satisfies. The second one, what it says in the second one, n, here what is n? N is equal to 2. 2 has to be a natural number. This is also right here. This satisfies. Now whether, let's see whether the condition 3 also satisfies. This n root a that is equal to 2 root 9 has to be an irrational number. Whether this 2 root n, that is square root of 2 root 9 or square root of 9 is an irrational number? No, this is equal to 3, which is not an irrational number. That means this does not satisfy the condition 3. So the square root of n is not a surd. Okay, this is one example. This is another example, and let us take one more example. Let us see whether 1 plus square root of 5, whether this is a surd or not. So all the three conditions has to satisfy, then only we can consider it as surd. What is the first condition says here? The square root of 1 plus root 5 means this is 2 here. If you compare it with n root of a, then the first condition is a has to be a positive rational number. What is a? A is equal to 1 plus root 5. Is this a positive rational number? No. Positive rational number? Is this a positive rational number? No, this is not a positive rational number. So it does not satisfy the first condition. So this is not a surd. We don't need to check the other conditions. If it does not satisfy any one among the three conditions, then this is not a, the number is not a surd. Okay. Then one more example. Let us take fourth root of 36. If you compare it with nth root of a, the first condition, a has to be a positive rational number. What is a? A is equal to 36. This is a positive rational number, right? Now check the second condition, whether n is a natural number. N is equal to 4 is a natural number. So it satisfies the second condition also. Now let us see the third condition. N root a, that is 4 root of 36, has to be irrational number. See, this 4 root of 36 means 2 root of 6, and this is an irrational number. So this satisfies the third one also. Okay, so this is a surd. Fourth root of 36 is a surd. Okay. Now, one statement you have to remember, that every surd is an irrational number. But every irrational number is not a surd. Suppose example, if I take an example of 2 root of 3, this is a surd plus irrational number. 5 root of 7, this is also surd plus irrational number. 2 plus root 13, this is also a surd plus irrational number. But if I consider pi, this is not surd but irrational number. If I consider 1.0100100001 dot dot dot, this is also not surd but irrational number. Okay, this one you have to remember. And some other things like unit surds. What is this? Nth root of a, that is, for example, we can say 3 root of 5. This is unit surd. Multiple surds. M into n root of a, where m is a rational number. Example, 5 into root 3. This is multiple surd. Okay, and mixed surd. B plus n root of a, b minus n root of a, where b is not equal to 0. Examples: 2 plus root 3, 2 minus root 3. These are okay. Now you remember what is rationalizing factor. If the product of two surds of a rational number If the product of two surds is a rational number, then each of the two is rationalizing factor of the others. I think you haven't understood. If the product of two surds, suppose example, this square root of a and square root of b. If we multiply these two, square root of a into square root of b, these two are surds. Okay, surds. That means necessarily these are irrational numbers. If we multiply these two, square root of ab, if this becomes rational number, then square root of a is rationalizing factor of square root of b, and square root of b is rationalizing factor of square root of a. Okay, let us understand with practical example. If we take root 5, can I say that root 3 is a rationalizing factor of root 5? Let us check. So what we have to do, we have to multiply root 3 with root 5. Root 3 into root 5 first, and this comes to be root 15. Is it a rational number? No, this is not a rational number. This is not a rational number. Not a rational number. So this statement is wrong. Can we say that root 5 is a rationalizing factor of root 5? Let us check. So we have to multiply root 5 with root 5. Root 5 into root 5 is equal to 5, which is a rational number. So this statement is correct. This one is wrong and this one is correct. Can we say that 3 root 5 is a rationalizing factor of root 5? Let us check. 3 root 5 into root 5 is equal to 3 into 5 is equal to 15, which is a rational number. So our statement is correct. Okay. Similarly, can we say that 1 plus root 2 is a rationalizing factor of 1 minus root 2? What we have to do, we have to multiply with this and multiply this, and we have to check whether the product is rational number or not. Let us check. 1 plus root 2 into 1 minus root 2 is equal to a plus b into a minus b, that is equal to a square minus b square, that is equal to 1 minus 2, that means is equal to minus 1, which is a rational number. That means our statement is correct. Okay. So with the help of the theory that we have learned on rationalizing factor and surds, let us solve one problem. Problem number 19. The simplest rationalizing factor of cube root of 500 is, there are four options: square root of 5, 3, cube root of 5 and cube root of 3. Which one is correct? First understand the question. Simplest rationalizing factor of 3 root 500. Which one is the rationalizing factor of 3 cube root of 500? So how we will determine which one is the rationalizing factor? We have to multiply. Suppose option A is the correct answer, then we have to multiply the option A with cube root of 500, and then we have to check whether the product is rational or not. If the product is rational, then our answer is correct. Let us check with option A. 3 cube root of 500 into square root of 5. So what we can do is cube root of 5 into cube root of 100 into square root of 5. That means 5 to the power 1 by 3 into 3 cube root of 100 into 5 to the power 1 by 2. This is not rational number, not rational number. From the expression itself we can say this is not rational number. Okay, now let us take the example, let us take the option 3 B. If we multiply cube root of 500 with 3, so this becomes 3 into cube root of 500. This is also not rational number. And now let us take the option 3, cube root of 500 into cube root of 5. It looks like rational number. So 500 to the power 1 by 3 into 5 to the power 1 by 3. So we know that this one comes to be like 500 into 5 whole to the power 1 by 3. How we know? We have learned the formula a to the power m into b to the power m. We can write it as ab to the power m. From that only we have found it. So this is like 2500 to the power 1 by 3. This is also not rational number. If instead of 1 by 3, if it was 1 by 2, then we could have said that this is a rational number. This should have been become 50. If it is square root of 2500, this would have become 50. Now let us check with the option D, this one. So cube root of 500 into cube root of 2, 500 to the power 1 by 3 into 2 to the power 1 by 3. So we are multiplying 500 into 2 whole to the power 1 by 3. So this becomes 1000 whole to the power 1 by 3. This is equal to 10, because 10 into 10 into 10 is equal to 100,000. Okay, so 10 cube is equal to 1000. That means 10 is equal to 1000, 1000 to the power 1 by 3. So this is a rational number. So our option, which one is correct? Option B. Okay. Now let us go to the problem number 20. This looks like a difficult problem. So let's see whether we can solve it or not. Okay, let us start. So 9 we can write it as 3 square whole to the power n into this 3 square into 3 to the power n minus 27 we can write as 3 cube whole to the power n, and this is 3 to the power 3m into 2 cube is equal to 1 by 27. Okay, let us first understand the question. It is given like 9 to the power n into 3 square into 3 to the power n minus 27 to the power n by 3 to the power 3m into 2 cube is equal to 27. Then what I have to prove? M minus n is equal to 1. Okay, can I write it as 3 to the power 3 square whole to the power n means 3 to the power 2n? We can write. I think we can. A to the power m whole to the power n is equal to a to the power m into n. We have learned. That is what I have written, into 3 square into 3 to the power n minus this also I can write as 3 to the power 3n. 3 to the power 3m into 2 cube is equal to 1 by 27, or this 3 to the power 2n plus 3 to the power n, that means 3 to the power 2n plus n into 3 square we can write minus 3 to the power 3n by 3 to the power 3m into 2 cube is equal to 1 by 27. We have done nothing. See, these two I have arranged. I have kept this one separated. Okay, and how I have arranged? 3 to the power 2n plus n. That is what I have written. Okay, now I can write 3 to the power 3n into 3 square minus 3 to the power 3n by 3 to the power 3m into 2 cube is equal to 1 by 27. Let us come to this side, or let us not waste this space and use it. I can take this 3 to the power 3n common लेते हैं. 3 to the power 3n, then what remains? This is 3 square minus, what will remain here? 1 into 1 if I write, then 1 by 3 to the power 3m into, let us write 2 cube is equal to 8, or 3 to the power 3n into, what is this? 3 square minus 1, 3 square means 9 minus 1 is equal to 8 by 3 to the power 3m into 8 is equal to 1 by 27. 8 कट गया. चलो, that means this is 3 to the power 3n minus 3m. If I take these two, is equal to 1 by 27. Or this 1 by 27 I can write it as 3 1 by 3 to the power 3. Okay. Again I can write it as 3 to the power minus 3. So what will this become? 3n minus 3m is equal to minus 3. So we can write as m minus n is equal to 1. Proved. This looks very difficult, but not that difficult problem. Now, question number 21. What is there? If a, b, c is equal to 1, that means a into b into c is equal to 1, show that 1 by 1 plus a plus b to the power minus 1 plus 1 by 1 plus b plus c to the power minus 1 plus 1 by 1 plus c plus a to the power minus 1 is equal to 1. Pause for a moment and try to solve it by yourself if you can. And if you can't, then I am here to help. Let us start. Let us see how we can solve LHS. Left hand side we are writing it as 1 by 1 plus a plus b to the power minus 1 plus 1 by 1 plus b plus c to the power minus 1 plus 1 by 1 plus c plus a to the power minus 1. We know that a, b, c is equal to 1. How to solve? We will write it as 1 plus a plus 1 by b plus 1 by 1 plus b plus 1 by c plus 1 by 1 plus c plus 1 by a. This minus 1 we can write as 1 by a. That is what I have written. Now what to do? There isn't much thing to do, but what we can do, we can, among these three unknown variables a, b, c, let us remove any one of them. Let us remove c. So instead of c we can write as 1 by ab. Okay, and let's see what it shows. So this is 1, this is b plus ab plus 1 by b plus 1 by 1 plus b plus this c is equal to 1 by ab. That means 1 by c is equal to ab plus 1 plus, instead of c I am writing ab plus 1 by a. This b will go to the numerator, right? So b plus ab plus 1 plus 1 by 1 plus b plus ab plus, can I write it as ab? Then this will be ab plus 1 plus b. Am I writing it correctly? I think I am writing. So b by, let us rearrange it as 1 plus b plus ab. This will become 1 plus b plus ab. So this will go above ab by, and rearranging it 1 plus b plus ab. Does it look easier now? Can we solve it? Yes, we can. 1 plus b plus ab, b plus 1 plus ab. 1 plus b plus ab, 1 plus b plus ab is equal to what is equal to RHS, and it's proved. There is nothing is there in this problem. Very easy problem, but it looks difficult. If you know the way how to solve it, if you think, then you can solve it. Question number 22. If a, b, c are distinct positive prime numbers such that a square into b cube into c to the power 4 is equal to 49392, then find the values of a, b and c. How to do it? It's only given a square into b cube into c to the power 4 is equal to 49392. We have to find a, b and c. How to? Do you find any options how to solve it? I cannot. So what is left? Let us factorize this. Let us factorize by prime factorization. Let us factorize 49392. If we factorize, at the end 2 is there, so it will be divided by 2. 2 2s are 4, 2 4s are 8, 3, 6, 13, 6, 2 is a 4, 1, 3, 9. This is 9. Then 6 is there, so again it will be divided by 2. So 1, 2, 3, 4, 1, 6, 8. Okay. 8 is there, so it will be divided by 2. 6, 7, 4, 2, 7, 4, 6, 1, 7, 4. Again 4 is there, so it will be divided by 2. 2, 3, 0. 7. So by prime factorization, we are getting these are the factors. So how many 2's are there? How many 2's are there? Total 4 numbers. How many 3's are there? Total 2 numbers. And how many 7's are there? How many 7's? 3 numbers. All are prime numbers. Okay. So this a square b cube c to the power 4 is equal to 49392. This we can write a square b cube into c to the power 4 is equal to this 2 to the power 4 into 3 to the power 2, that is 3 square into 7 to the power 3. Okay, so if I rearrange it accordingly, square cube and 4 to the power 4, then what we are getting, a square b cube c to the power 4 is equal to 3a square into 7 cube into 2 to the power 4. See, now if we match the powers, then what we are getting, this power, we are matching the powers, like this square we are matching with this one, and then we are matching this cubic with this one, and again we will match this fourth power with this one. Then what we will get, this a square is equal to 3 square, that means a is equal to 3, this b cube is equal to 7 cube, that means b is equal to 7, and c to the power 4 is equal to 2 to the power 4, that means c is equal to 2. A is equal to 3, b is equal to 7, and c is equal to 4. And all this a, b, c are prime numbers. Okay, prime integers. Initially it has been written that a, b, c are distinct positive prime integers, and these are prime integers, distinct prime positive integers. Okay, so we have got the answer. This is the type of question. This may also come in exam. Next question, question number 23. If x is equal to cube root of 28 and y is equal to cube root of 27, find the value of x plus y minus 1 by x square plus xy plus y square, that you have to find. Okay, how to find it? If you try to get x plus y, this will be irrational, and this will look irrational because cube root of 28 is irrational, but cube root of 27 is not. So x plus y also you cannot find, and even x square and y square are also not possible to find. So how to solve it? So do you know the formula of x cube minus y cube is equal to x minus y into x square plus xy plus y square? Just remember this formula. This formula is needed to solve this problem. And now see how I am solving this problem. X plus y minus x square plus xy plus y square. Why I need this formula? Because anyhow, if I can make this portion in cube, then the x cube or y cube, then it will be very easy for me to solve it. Because if x is equal to cube root of 28, then x cube is equal to 28. So let us see if we can make it or not. X plus y is equal to, so if I multiply on the denominator x minus y, and also in numerator we have to multiply it and make it x square plus xy plus y square. So it's x minus y. So now what is this? Is this not x cube minus y cube, what I have written here? Isn't it? So I can write it as x cube minus y cube. Okay, so it is x plus y minus x minus y by, now let us put the value of x cube minus y cube. X is equal to cube root of 28, that means x cube is equal to 28, and y is equal to cube root of 27, that means y cube is equal to 27. So x cube is equal to 28 minus y cube is equal to 27. Now x plus y minus, let us take it in bracket, x minus y by 1. X plus y minus x minus y. So x plus y minus x plus y. 2y. That means 2 into cube root of 27. And what is cube root of 27? 3. That means this is equal to 6. Question number 24. A to the power x is equal to b, b to the power y is equal to c, and c to the power z is equal to a. You have to prove that x, y, z is equal to 1. This is a very easy problem. A to the power x is equal to b, and b to the power y is equal to c, and c to the power z is equal to a. So when c to the power z is equal to a, we can write c is equal to a to the power 1 by z. We can write, or that means b is equal to c to the power 1 by y, and b is equal to, instead of c I can write a to the power 1 by z whole to the power y. If I write it as equation 1, we can write from equation 1. That means b is equal to a to the power 1 by yz, right? Now this we are writing as equation 2. Now a to the power x is equal to b. This is given. Okay, so I can write a to the power x is equal to, instead of b I can write a to the power 1 by yz. From where? From equation 2 I got. So matching the both sides, I can write as x is equal to 1 by yz. That means x, y, z is equal to 1. Proved. Very easy problem. Okay. Now the question number 25. If a to the power x is equal to b to the power y is equal to c to the power z and b square is equal to ac, you have to prove that y is equal to 2xz by x plus z. Okay. So how to do that? You have to remove all this ABC, all these things, then only you will get this problem. So how we will do? A to the power x is equal to b to the power y is equal to c to the power z. How to remove this ABC from this one? How to remove? And this b square is equal to ac. If I remove ABC from this one, and I can get the value of x, y, z or ABC and put it in this, then let's see what happens. Say a to the power x is equal to b to the power y is equal to c to the power z is equal to k. That means what we can write, a is equal to k to the power 1 by x. If a to the power x is equal to k, then can we write a is equal to k to the power 1 by x? We can write. Okay, so b is equal to k to the power 1 by y. Similarly, c is equal to k to the power 1 by z. Think like a to the power x is equal to k. If I multiply on both sides, a to the power x whole to the power 1 by x into k to the power 1 by x, then it becomes a to the power x into 1 by x is equal to k to the power 1 by x. So a is equal to k to the power 1 by x. That's what I have written, a is equal to k to the power 1 by x. This we can write, and we are putting this value in this, and let's see what happens. So b square, b means k to the power 1 by y whole square is equal to a. What is a? A means k to the power 1 by x, and what is c? C means k to the power 1 by z. This is equal to k to the power 2 by y is equal to k to the power 1 by x plus 1 by z. That means 2 by y is equal to 1 by x plus 1 by z. That means 2 by y is equal to z plus x by xz. That means we are putting this, throwing this y this side and taking all this in this side. That means y is equal to 2xz by 2xz by x plus z. Rearranging this z plus x as x plus z. Hence proved. Okay. Now the longest question have come. This is the longest question and maybe the most difficult question. कुछ नहीं है, घंटा difficult है, very easy. Let us try to solve. Okay. So LHS is equal to this, and this what we can write 1 by 1 plus root 2 plus 1 by root 2 plus root 3 plus 1 by root 3 plus root 4 plus 1 by root 4 plus root 5 plus 1 by root 5 plus root 6 plus 1 by root 6 plus root 7 plus 1 by root 7 plus root 8 plus 1 by root 8 plus root 9. Abhi, you have to rationalize it. To rationalize it, what you will do? 1 minus root 2, you will multiply it with. So this is 1 plus root 2 into 1 minus root 2. Similarly, this also root 2 minus root 3. We will multiply it on both numerator and denominator to rationalize it. So this is root 2 plus root 3 into root 2 minus root 3. This is root 3 minus root 4, this term, by root 3 plus root 4 into root 3 minus root 4. Again, this term we are writing as root 4 minus root 5 by root 4 plus root 5 into root 4 minus root 5. So now this term we are writing as root 5 minus root 6 by root 5 plus root 6 into root 5 minus root 6. Now this term root 6 minus root 7 by root 6 plus root 7 into root 6 minus root 7 plus this term we are writing root 7 minus root 8 by root 7 plus root 8 into root 7 minus root 8. Again this one, root 8 minus root 9 by root 8 plus root 9 into root 8 minus root 9. So what we are going to do, I'll do one step jump, just be with me. This is equal to a plus b into a minus b. That means 1 square minus root 2 square. That means 1 minus 2. So I'll write 1 minus 2. Similarly, what will be this? Root 2 minus root 3 by root 2 square minus root 3 square. That means root 2 square means 2 and root 3 square means 3. Similarly, root 3 minus root 4 by 3 minus 4 plus root 4 minus root 5 by 4 minus 5, root 5 minus root 6 by 5 minus 6, and then root 6 minus root 7 by 6 minus 7 plus root 7 minus root 8 by 7 minus 8 plus this one, root 8 minus root 9 by 8 minus 9. Okay, what I have done, this one root 2 square minus root 3 square, that means 2 minus 3, this is root 3 square minus root 4 square is equal to 3 minus 4. Similarly, it goes on. And what is this? 1 minus root 2 by minus 1 plus root 2 minus root 3 by minus 1 plus root 3 minus root 4 by minus 1, root 4 minus root 5 by minus 1 plus root 5 minus root 6 by minus 1 plus root 6 minus root 7 by minus 1 plus root 7 minus root 8 by minus 1 plus root 8 minus root 9 by minus 1. So we can write it as minus 1 plus root 2 minus root 2 plus root 3. If this minus comes first, then the second term will be positive. First one is negative, second term positive. Then similarly, this first term will become negative and the second term will become positive. Similarly, this is root 3 plus root 4. And similarly, this one root 4 plus root 5. This one minus root 5 plus root 6. This one minus root 6 plus root 7. Then this one minus root 7 plus root 8. This one minus root 8 plus root 9. So now let us check what is deducted. This root 2 root 2, root 3 root 3, root 4 root 4, root 5 plus root 6 minus root 6 plus root 7 minus root 7 plus root 8 minus root 8. So what is left? Minus 1 plus root 9 is equal to minus 1 plus 3 is equal to 2. That is what we need to prove. Hence is equal to RHS. Proved. A little bit lengthy but not a difficult problem. Okay. So this is the last problem that we will be solving. If x is equal to 3 plus 2 root 2, find the value of root x square root of x minus 1 by square root of x. How to solve it? If we take square root of x, x is equal to 3 plus 2 root 2, and if we take square root of x, this will become 3 plus 2 square root of 3 plus 2 root 2, and if we are going to take 1 by square root of x, this will also become square root of 3 plus 2 root 2, and we have to rationalize it. How to rationalize? It will be difficult to rationalize these things. You have to do 3 plus 2 root 2 by this square root of 3 plus 2 root 2 whole square. Then it will become 3 plus 2 root 2 by 3 plus 2 root 2. Again, rationalizing will be difficult, and ultimately you will not get the value of this x minus 1 by this root x minus 1 by root x. So how to get the value of this? Can we try to get the value of, instead of root x minus 1 by root x, let us try to find the value of root x minus 1 by root x whole square, and let's see what we get. Okay, let's see what we get. This is equal to a minus b whole square. What is this? If we expand, a square minus 2 into a into b plus b square. So what is root x square? This is nothing but x, and this 2 cut minus 2 plus this will be 1 by x. So this is nothing but what we are getting, x plus 1 by x minus 2. We know x is equal to 3 plus 2 root 2. Instead of finding root x, square root of x, or 1 by square root of x, it is difficult to find 1 by x. This will be 3 plus 2 root 2. And the rationalization, how do we do rationalize it? 3 minus 2 root 2 by this 3 plus 2 root 2 into 3 minus 2 root 2. On both numerator and denominator, we are multiplying with 3 minus 2 root 2 to rationalize the denominator. This will be 3 minus 2 root 2 by this 3 square minus 2 root 2 square. So 3 minus 2 root 2 by this 3 3 is a 9 minus 2 2 is a 4, 4 2 is a 8. That means 3 minus 2 root 2. 1 by x is equal to 3 minus 2 root 2. X is equal to 3 plus 2 root 2. 1 by x is equal to 3 minus 2 root 2. Let us put the value of x is equal to 3 plus 2 root 2 and 1 by x is equal to 3 minus 2 root 2, and then minus 2 is remaining. ये 2 root 2 कट गया. So what is remaining? 3 plus 3 6 minus 2 4. Okay, and now what is this? 4 is equal to x square root of x minus 1 by square root of x whole square. So now what is square root of x minus 1 by square root of x? This is equal to 2. I mean, we can write it square root of 4 is equal to 2. Okay, we have found the value. So this is the end of the chapter. We have solved 27 number problems. While reading the theory also, we have solved some examples, and for specially solving the numericals, we have done 2 lectures. In earlier also 1 lecture, while we have solved 13 problems, and in this video also we have solved some more problems. Total 27 number of problems we have solved. Some advanced problems also we have solved, and I hope this will be helpful for your exam purposes. And I have almost covered all the problems, all types of problems what can come in exams, in your board exams, in your school exam, half yearly or annual exam, or even in competitive examinations also. Okay, so thank you for supporting me. Please support the channel. Please like, share and subscribe the channel. Thank you.